Hello all, welcome back to AK App Logics. Today we are going to discuss about the some examples related to the sized format which is discussed by us previously. I have explained you, but I was watched the video, but I think you may get confused, right? So I'm taking some of the example to explain this particular topic from number format to sizing numbers. Okay, without any delay, let's go into the video. So this is the code 8. It is the actual code. Okay, yeah. Um, this code is to check whether the C style is working or not, which means what it will check is if you're gonna see over here, I have represented 16 as in decimal and 0x10 in hexadecimal and 1 4 zeros in binary and 0 2 0 in octal. As I told in the number format video that this is the representation format in C language. So what we're gonna do is whether this particular format is being worked to the Verilog or not. Okay, that's the thing that we are going to check. Okay. So this is the module. Don't worry about this. I will explain in the coming videos. Any code should be written in the module and end module. In between module and end module, this is the module name, and we should end with semicolon. And there is an integer. I have taken four integers because we have four number systems. Those are decimal, binary, octal, and hexadecimal. And this is the initial block. Initial block. It should be started with begin, and we should end which is similar to the curly braces. Okay, in C we use curly braces. Okay, whereas in Verilog we gonna use begin and end. Okay, I have represented this particular thing. See, this particular thing. Okay, I have represented. Sorry, yeah, I have represented these things. Okay, okay, these things in yeah. I have represented some numbers. Those are these things. Yeah, some numbers in decimal 10 in this 0x will be hexadecimal and 1012 starting there is 0, so it will be treated as octal in C language. This is 1010, it will be binary. So I have taken assumption that and assigned four different values to the ABCD. Those are in the formats of decimal, binary, octal, and hexadecimal. As per my assumption, I took the C language assignment. Okay, so let us check whether it is working or not. Okay, so let me check this. Let me run this. As I have told previously, this this is the command used to run. So we got an error. What is this error? So this is the syntax error. It means let us copy this error. Which line? 99. We want to see 99. This is the hexadecimal representation. So we got error over here, which is syntax error. At the same, we got malformed statement. Okay, we have got two errors. Okay, these are the errors. So let us comment this particular thing and check whether it means with this particular thing we can able to see that hexadecimal format as in C language can't be able to use it in the Verilog. Okay, so let us check whether the other three decimal and C language. Okay, so actually I have taken value of 10. Okay, a value of 10 in four different systems. So, and I have used in the display statement, it is similar to the printf statement. In display statement, I have used the percentage d. So, what I have to get is The answer must be 10 for all the values. For all the values A, B, C, D, the answer must be 10. Why? Because I have used the percentage symbol as D and I have used the value 10 in all different formats. Value 10 is in decimal, and in hexadecimal it will be A, and in octal it will be 1, 2, and in binary it will be 1010. Okay, so let us, for the first case, we don't get the uh, value. Why? Because hexadecimal statement is syntax error. So we have confirmed it. Let us confirm other systems. So again, I am gonna run. So the code is compiled. Okay, let me execute the code. So if you're gonna see over here, so we got A equal to 10, C equal to 12, and D is equal to 1010. But what is our expected output is 10 for all the cases. Why? Because we have used percentage D. Even though we have represented the numbers in different systems, we have used the percentage D. So it must be 10. Why? Because all these numbers are same. Okay. A is in decimal, B is in hexadecimal, C is in octal, D is in uh, binary format of 10. Okay. So we have commented the B, right? So that we got B value as X. Okay. Which is the default value of integer. Okay. And A equal to 10 we got, and C equal to 12 we got, D equal to 1010 we got. We didn't get 10, which is our actual expected output. So from this we can able to say that we can't able to use this particular C language format, which is I have discussed over here, right? So we can't able to use this. So I hope you got this point. So let us comment this particular uh, code. Okay, let me comment. So let us discuss next code. This is the code. Similarly, I have discussed done declared four variables, which are the integer types, and I have used three tick B. B means binary, and I have used 010. After B, I have mentioned three numbers so that I given size as 3. Okay, and I have represented a decimal number. So this is the one, right? Yeah. Okay. So after D, I have represented one number, so I have given size as 1. Similarly, for octal, after O, I have given 70, which is the two numbers. So I have given it as 2. For H, after H, we have three numbers. I have given it as 3. So if you run this code, so this is your assumption, right? Previously, I have discussed this point nearly 10 times. So it will be wrong. Why? Because if you're gonna represent these particular numbers in binary, it will be 010 as it is binary, and it will be 100, and it will be 111 underscore, let us use 00. Okay, and it will be 1 underscore 111 underscore 1010, right? So we have to take the binary bits. Here we got the error. If you wanna see those errors, 114. What error we got? Warning: number constant truncated to 1 bit. It means the actual 114 is the decimal number. The actual representation of 4 in binary is 100. So, but we have mentioned size as 1 bit. what you have thought is, after decimal base format, we have given only one digit, no? So we have to use the size as 1, like that we have assumed, and we have given the size as 1. But actually the 4 is, how the 4 is being represented in binary, it is being represented in 100, which is actually 3 bits. So what does this warning says is numeric constant truncated to 1 bit. It means the actual bits that are used to represent 4 is 3 bits, but we have mentioned size as 1 based on the wrong assumption that after D, which is the base format, we have used only one digit, that is 4. So by this, the two digits that are 1 0 are being truncated. Okay, are being truncated. Okay, let me run this code, then you will understand. So, and we will get answer as 0. Let me, yeah, see. We got first value as same as 2 because we don't have any errors. Why? Because we have used 3 bits, and we have given 3 sizes 3, and actual representation of these particular 3 bits in binary is 0 1 0 itself, so we didn't get any error, so we got the value as 0 2. Okay, but for the second value, as I have told previously, 2 bits are being truncated because I have given size as 1, but actually the 4 is being represented with 3 bits which are 100. The LSB is only gets printed over here, so that the B value is 0 and 1 0 are being truncated. So this is the warning. Actually, this is not an error. This is a warning, so that only our code is being uh, executed and we got an output. Okay. So, and if you're gonna see the 115 error warning, so 115 warning this is. So actually, the binary representation of 70, which is an octal number, is triple one triple zeros. Okay, so there are two warnings. What is this two warnings mean? Means the first warning is extra digits given for sized octal constant. It means we have given an extra digits. We have mentioned size as 2, but have given 6 digits, right? We have mentioned size, it will be size will be 2. We have given 6 digits, so that this warning tells that. Okay, and the second warning, which is quite contrast to this. Okay, quite contrast to this, that is numeric constant truncated to 2 bits. Okay, it means the first thing is extra digits are given for the size octal constant. We have mentioned size as 2, but we have given 6 binary bits. Why we have given sizes 2? Because of the wrong assumption. Most of the people think that after O there are only two digits are represented, and we should give 2 as the size. They will think like that. But the thing is, we have to represent this particular uh, number into the binary. Then we have to count how many bits are there to form this particular number. That particular number of bits we should give as size. Okay, so that it is telling that extra digits are given for the size octal constant. And the second thing is we have given extra digits, right? Instead of giving two digits, we based on the wrong instead of giving here 6, we have given 2, so we have given extra digits, right? So but the size is 2, right? So extra bits, 4 bits will be truncated, and the last 2 bits only will get printed. That is the last two digits value will be 0, right? combinedly the last two digits value will be 0, so the 0 is get printed. Okay, yeah. And the second error is numeric constant truncated to 2 bits. Why only it truncated to 2 bits? Because we have given size as 2. The previous case we have given size as 1, so the numeric constant truncated to 1 bit. It means it will get truncated to our given size, okay, and neglect other bits. So with this we will get a wrong answer. Instead of getting 70 as answer, we are getting 0 as answer. So which is not an expected output. Even though the code is getting compiled, it will be the runtime error. Okay. Yeah. So let me also copy this warning. So I think I am explaining you in a better way. You guys need to practice, then only can able to understand all these points. So similarly for the third case, 116 warning extra digits given for x, size it x a constant. Actually we have mentioned 3, right size. Why after h we have given 3 particular hexadecimal digits. So we have with the wrong assumption we have given size as 3. So, but the actual representation of this particular number in binary will be 12 digits, 12 bits, right? Instead of giving here 12 bits, we have given 3, so that it is saying that warning extra digits given for sized constant. Okay, similar to the case of uh, case of octal. Okay, next, and the second thing is numeric constant truncated to 3 bits. It means the value, the size of this particular thing is only 3 bits, right? So that it will be showing us, it will be taking only 3 bits and neglecting all these bits. So when it will take the 3 bits, the value will be 010. It particular corresponding hexadecimal value will be 2, so that the 2 is got printed in the output. Okay, yeah. So let me copy this error and also mention there. Okay, warning. These are the warnings. These are not the errors. If these are errors, then our code won't execute. Okay. I hope you got this point, which is a blunder mistake. So I have kept the heading as blunder mistake. These are the very. This looks like very small thing, but most of the people do this type of blunder mistakes. So I am taking more time to explain this things. Why? Because it should able to give you a clarity. Okay, why only like this, why it has been happening, all these things. So programming is not a theoretical concept, it is a practical concept that I always believe, so that I'm executing codes for you guys. Okay, to make you understand in very better way. Okay, yeah, let me display other code. Yeah, if you're gonna see this code, this is also similarly code, but I have modified the sizes. Here binary three binary bits are there, so I have mentioned 3. And for decimal, I have mentioned size as 3 because 100. We can represent 4 as 100, which requires 3 binary bits, so I have given size as 3. Okay, for octal, we can able to represent this particular number in 6 digits, right? So 6 binary bits. Okay. So that I have given size as 6. And for hexadecimal, we can able to represent this particular number in 12. So I have given 12 as size. Okay. Okay. Yeah. So if you're gonna run this particular code, let's see whether the values are getting correctly or not. So you can see, able to see over here, we are getting the correct values. Actually, I have used this particular thing as B. I'm gonna change this. Okay, let me run again. See, if you're gonna see over here, we got the correct values, right? Binary we got 2, 1, 0, it will be 2, right? For B we get value as 4 because we have used different format space. We can all you can see over here. For A we have used percentage 0 B. 0 is nothing but is used to avoid the spaces of after equal to in output console. Okay, 0 we will use for that reason. So we have used A because A percentage B for A because this is a binary number. For B, we have used percentage 0D because it is a decimal number, and for C, we have used percentage 0 O. Why? Because it's a octal number. For D, we have used hexadecimal. So if you can see over here, I have used capital O, right? We can use format space where either it may be a capital or it may be a small. Okay, and I have used small b and small d, whereas I have used capital O and capital H. Is it? Yeah. Let's is we got the same output, right? Same thing, right? Yeah. Is it really rectified? The question is it really rectified? So let's that will be discussed by with other code by modifying small change. Okay. If you're gonna see this particular code, everything is same for this code and this code, but the only difference is I have used, let me change this format specified. Here, in this case, I have mentioned the size of hexadecimal as 12, and here I have mentioned size as 9. The only difference is this only. Okay. Why I have mentioned over here 9 means if you're gonna see this particular representation of this number in binary bits, this is the particular number. Okay. Yeah. So if you're gonna see this, the leftmost three bits, the leftmost three bits, that is MSB bits, most significant bits, okay, are zeros, right? We can able to neglect this, right? So then the number will become how many number of digits? 9 digits, isn't it? So I mentioned size as 9. So, what is the difference between 9 and 12? They are quite nearer to each other, right? We can able to ask this. This will reduce the size of memory, the storage of this memory, 3 bits. Okay. In this case, this particular code will occupy 3 more bits than this, right? So we have reduced the 3 bits, right? Actually, isn't it? So every minute detail is most important. So that's the thing I am gonna explain very detailed. Okay. I hope you find the difference between this particular code and this particular code. The only difference is this thing. Okay. You can also do for this as well. You can also represent this as 2, right? And you can remove this 0. There is no problem, right? Then it will be 1 0. And for 4 we can't able to do it because 100 the MSB is 1, and for 7 also we can't able to do 70. Why? Because the MSB is 1. And for this particular thing we can able to do so that I am gonna truncate all those 3 zeros and I'm gonna represent like this. So if you're gonna run this particular code, the result will be similar to the previous one. So you can able to see this, right? That's the thing. Let's move on to the some other code. I think you got this thing right. The main actual part of this video is this particular thing. This is the most important thing. Okay, this is the blunder mistake. Even I have made this particular mistake nearly 10 to 20 times. Mostly, I use it to make those mistakes. Yeah, let me discuss some other code. Yeah, this is the code, the next code. Okay, yeah. So the main difference is I have used the base formats B, D, O, H as caps in this case. Previously, I have used them as small one. Okay, let us see. And also the format specifiers also I have used as caps. Let us see whether it is going to work or not. Yeah, let us compile. So, sorry, sorry, just wait a second. Sorry for the interruption. Yeah, so this is the thing. I have just changed the. Okay, let me here. Let me run this code. Okay, so there is an warning. Where is the warning? 153. Let me remove this particular zero. Yeah, let me run again. So you got the same thing, right? Even we are going to use capital base format and capital format specifier. We got the same thing. And even we use if we use the small format specifier and capital format small base format, we got the same thing, same result. It means we can able to use format specifiers and base formats as caps and small letters. Okay, let's move to the next code. Yeah, yeah, guys. This is the code. Okay, I have represented 10 number in four different formats, and I have used for percentage D. And let us check whether we are getting all the values same or not. Okay, yeah. See, we are getting the all the values similar, right? Right? Yeah. Let's move to the next code. This is also the similar code to the above code, and we are gonna use the underscores between the numbers. That's it. So let us see whether it's going to work or not. Yeah. So there is an error. Why? For all the 179, 180, and 181 and 182, all the lines have been given with errors. Why? But in the previous lecture, I have told you that we can able to use the underscore between the number, right? But why we got the error? The thing is, we can able to use the underscore between number, okay? But initially can't able to start with a underscore after base format. We gonna see in the four cases after base format D, I have used the underscore. For that particular reason, we are getting the error. Okay, for that particular reason, we have getting the error. So let us see uh, by removing this underscore. Okay, yeah, yeah. See guys, we can able to see I have removed the underscore after base formats. And let us run this code. Yeah, let me clear first and let me run. This is syntax error. Where is it? 200. Yeah, sorry. I have used the next statement. Let me remove this and rerun it again. Yeah. So if we're gonna see, we got the values, right? 10, 10, and 10. This is the value I have used uh, hexadecimal value to represent the underscores. Okay. Yeah. From this we can able to write a note over here. Okay. That is, we shouldn't use the underscore immediately after the base format. Base format. This is the note point from the above two codes. And you can also able to see over here, I have represented capital C, small a, and capital F, small e. It means for the hexadecimal digits, we can able to use representing numbers in caps and small also. Okay. So it's been so long. It's already 30 minutes long. I thought to finish it in 15 minutes, but due to the code and due to the explanation of mine, it took a long time. So actually, I thought to type all these codes and tell you. If I do this, typing the codes will kill the time, right? So I just showing the codes. Okay, I wish you are going to practice these codes. I think I am imagining like that. It will be very useful. Okay, we have got a point, right? One important point that we haven't discussed. We got it, right? So I recommend you guys to work on coding. Okay, yeah, that's it for today. Let's meet tomorrow. Okay, bye.